video, let's take a look at domain and range. Domain is defined as the set of all possible inputs into a function, and basically you can think of it that as the x values that work in that function. Second thing would be range. Range is defined as the set of all possible outputs, the numbers that you get out of that function substitution when you plug a number in, and it would be the y values that work. If we take a look at a typical example of what you're looking for when you're trying to find the domain and range, you may have questions like this. What is the domain? What is the range of this graph? Now if we take a closer look at this graph, we can see that the process for finding domain and range is all about finding the minimums first and then the maximums. And think about what axis you're on. So you always begin with the domain on the x-axis, and you think about what is my minimum value, what's my smallest number, what's the least amount that has a value in this function. In this case it happens to be at -2. So -2 is my minimum number, that's the first number you write down, and then 7 is the next number you write down because that's the biggest number. So you write down -2 and 7, so you'd write something like this, the -2 and then the 7, and then you're like, okay, well I'm on the x-axis, so you put that in between. And you look at the dot that's in the corner. In this case, it's a closed dot. Therefore, by this key over here, if it's an open dot, it's either less than or greater than. If it's a closed dot, it's less than or equal to or greater than or equal to. So this is a closed dot. This point counts. Therefore, -2, the value itself, this -2 value, is less than or equal to all the other values over here. And then as the x values continue to grow, they go to 7 on the x-axis, but they do not include 7 because that's an open circle. So the domain would be -2 is less than or equal to x, which is less than 7. The range, the lowest number is -4. Write that down first. The highest number is 5. Write that down next. What axis are you on? You're on the y-axis. Then as soon as you have that figured out, now you can figure out your values. Well, this point counts, so -4 is going to count. Therefore, -4 is less than or equal to all these y values as you're traveling up, which is then less than 5. All right, take a look at the next one. The next one is the first one was kind of a segment. This is a ray, an open circle ray here. This point doesn't count, but the rest of these points count off in this direction. So if we take a look at the x-axis, what is the smallest number? -6. What is the largest number? It's heading towards infinity. So the domain would be -6, and it's heading towards infinity. And we're on the x-axis. So if that's the case, then this point right here doesn't count because -6 is less than x, which is less than infinity. You can never reach infinity, so you will not have a less than or equal to symbol here. It would be less than. Now, anytime you're having infinity as part of your domain and range, that should be assigned to you. You could write it another way. You could write it in a way that it just heads off into one direction. In this case, all of the x values are greater than -6 is the other way to write it. That's the symbol that tells you that you can write it another way. Let's look at the range. The range bottoms out at 4. So 4 would be a first number I'd write down. And then if I look up the y-axis, where is it going? It's going towards positive infinity. So it's going to go from 4 to infinity. I'm on the y-axis. And the 4 values are less than the rest of the y values, which are less than infinity. Again, I've got that symbol. If you've got infinity involved, then you could just simply say, well, all the y values are greater than 4. Okay, let's take a look at a couple of special cases before I have you try two problems. The special cases would be when you have a line. If you were to graph a line, you could take a look back here. That thing's going to -infinity on the x-axis to positive infinity. So you could write this. The domain goes from -infinity all the way to positive infinity, and I'm on the x-axis. You could do the same thing for the range because it goes all the way down and all the way up. That doesn't do anybody really any good because you end up saying everything anyways. So the abbreviation for saying everything is denoted by the capital letter R with 2 vertical sticks. So you say capital letter R with an extra line on the bar here, and then that's all real numbers. And then the range, of course, would be all real numbers as well. And that would be a Y. And next, we have another special case. So you do have special cases where everything counts, and that would be all reals. You do have some cases where some things don't count. And when things don't count, we say a graph is heading towards a limit or towards an asymptote. And in this case, this graph is coming down. It's getting really close to -2 but never gets there. This part of the graph starts near -2, comes down, and gets away from it. So this graph never equals -2 on the y-axis. Same thing on the x-axis. It gets close to -3 and then drops off. It's coming from -3 and then it keeps going. So it never gets negative 3 and it never gets negative 2, but it gets every other number. So that's how we make the statement for its domain and range, is we can just say that the domain x doesn't equal negative 3 and the range x or y doesn't equal negative 2. It just misses those points. It hits everywhere else. And so we know that if you make this statement that you mean it hits everywhere else. Okay, now there are two problems down here that I would like you to try. Take a moment, pause the video. You can sketch these two, and then you can try to write out or author out your own domain and range. After you've paused the video, you can come back and check the answers. Here are the answers now that you've paused the video. The answers would be, you could start out on the x-axis as negative 4 to infinity, but another way to write that would be x is greater than negative 4. The y, the same way. The y is greater than or equal to negative 3. It does hit this negative 3 and go up, or you could write it this way, which is the long way, but that infinity symbol is telling you you should be able to rewrite it. And here are the solutions for the parabola.